And welcome to example 3, where we're going to find the center, the vertices, the foci, the asymptotes, and sketch the graph of x squared minus 9y squared plus 36y minus 72 equals 0. So this is not in our standard form. We're going to have to do some completing the square work in order to get this of the form x squared over something minus y squared over something equals 1. The big idea is we can't deal with a linear term. So I'm not going to have to do any completing the square with the x family because there are no linear x terms. But I am going to factor out a negative 9, which yields y squared minus 4y, and I'm going to pop the 72 to the other side. Now, when I take negative 4 divided by 2 and I square it, this yields a positive 4, but I didn't add 4 to the entire side. I added 4 to the inside of that parentheses, but what I really did was add a negative 36. So I need to subtract 36 on the other side in order to balance my equation. So I'm left with x squared minus 9 times the quantity y minus 2 squared equals 36. And in order to get this in the standard form, Harper, be quiet. I think my family is home. Harper, enough. I'm going to divide everything by 36. So I have x squared over 36 minus y minus 2, the quantity squared over 4 equals 1. And this is the equation that I'm going to deal with. So let's sketch what we have so far. Okay, I know that my center is going to be at 0, 2. Okay, I know because the x comes first, I have a horizontal transverse axis, so my hyperbola is going to be opening up left and right. So I'm going to be opening up left and right 6 units, since that is the square root of 36, to the right and to the left. Now I want to make sure that I get the right bend. So I'm going to plot my conjugate axis. So 4 is 2 squared, so I'm going to go 2 up and 2 down. And I'm going to create my rectangle. I know that the asymptotes are going to go through each of those corners. And so my hyperbola is going to look like this. There's my sketch. Okay, so my vertices, notice my vertices. My vertices are located at negative 6, 2 and at positive 6, 2. My asymptotes, in order for me to get the equation of my asymptotes, remember I need 2 things. I need a point. The point I'm going to use is the center 0, 2, and my slope. Well, my change in y over my change in x, from the center, I would go 2 up, and then I would go to the right 6. So I would have a third as the slope of the positive line, and I would have negative 1/3 as the slope of my negative line. So when I put those together, y minus 2 equals 1/3 x minus 0. So y minus 2 equals 1/3 x. So one of my asymptotes is 1/3 x plus 2, and that would represent that asymptote. And then my other asymptote would be y minus 2 equals negative 1/3 x minus 0. So y minus 2 is equal to negative 1/3 x. So y is equal to negative 1/3 x plus 2. And that would represent this line. Okay. So my asymptotes are y equals negative 1/3 x plus 2 and y equals positive 1/3 x plus 2. And last but not least, let's find our foci. I've got a little bit of room down here. So my foci is going to be c squared equals a squared plus b squared. This is similar numbers from a previous problem. So I get the square root of 40, which is between 6 and 7. Okay. So my foci is equal to a distance of square root of 40, which is 2 root 10 from the center. So from the center, 2 root 10 would be located here and here. So my foci points would be 2 root 10, comma 2, and negative 2 root 10, comma 2. And here we are on example 4. This problem is similar to the last one in that we're going to find all the information about the hyperbola, and we do not have a nice, wonderful equation. I'm showing you this problem because we're going to have to complete the square twice. All right, so I have 9x squared minus y squared plus 54x plus 10y plus 55 equals 0. I'm going to reorder my terms so that I have the x information together, and then I have the y information together, and I'm going to pop the 55 to the other side. Now I'm going to factor out a 9, and this yields x squared plus 6x. I'm going to leave a little bit of a space, and I do need to factor out a negative 1, which leaves me with the y squared minus 10y. Now I'm going to complete the square. Half of 6 is 3, squared is 9, but I'm not really adding 9. I'm actually adding 81 to the other side. And here, half of 10 is 5, squared is 25. So I'm not really adding 25, I'm subtracting 25 from that side. So when I factor, I'm left with 9 times x plus 3, the quantity squared, minus the quantity y minus 5 squared. And when you total negative 55 plus 81 minus 25, you're left with 1. So you might be wondering, well, I can't divide by anything to get rid of this 9. But remember, I can multiply anything by the number 1. So I'm going to multiply by 1/9 over 1/9. So what I end up with is x plus 3, the quantity squared, over 1/9, minus y minus 5 squared, technically over 1. It doesn't have to be written, equals 1 as my general form. So the center of my hyperbola is going to be negative 3, 5. Because the x comes first, I know that my transverse axis is horizontal, so it's opening up left and right. So let's graph what we have so far. So I'm going to go to negative 3. Oh, I didn't draw that very well. So 1, 2, 3, 1, 2, 3, 4, 5. Okay. My transverse axis is going to be a distance of 1/3 to the right and to the left. So that means my vertices are going to be negative 3 minus 1/3, comma 5, and negative 3 plus 1/3, comma 5. And when you simplify those, you get negative 10/3, comma 5. And this would be negative 8/3, comma 5 for my vertices. Now I want to be clear. I need to get my asymptotes so that I can draw a nice sketch. Well, the square root of 1 is 1, so I'm going to go above and below the center by 1. So notice my conjugate axis in this case is actually higher than my transverse axis. And I think that's my phone going off, if you can hear that in the background. All right, so there's an asymptote, and there's an asymptote. Okay. And I knew that my transverse axis was horizontal, so my branches are going to go in this direction. So when I need to get the equation of my asymptote, remember I need two things, a point, and I'm going to use the center, negative 3, 5. And the second thing I need is a slope, which is my change in y over my change in x. And from the center, I went up 1, and then I went to the right 1/3. Well, 1 divided by 1/3 is the same as 1 times 3. So my slope is 3 for the positive line, and for the negative line, it would be a negative 3. So when I put those together to get my equations of my asymptotes, and using point slope, y minus 5 would equal 3 times x plus 3. So y minus 5 is equal to 3x plus 9. So y is equal to 3x plus 14 is one equation of an asymptote. And my other equation is y minus 5 equals negative 3 times x plus 3. So y minus 5 is equal to negative 3x minus 9. So y is equal to negative 3x minus 4. And there's the other equation of my asymptote. So my asymptotes are y equals 3x plus 14 and y equals negative 3x minus 4. Last but not least, my foci. My foci is c squared is equal to a squared plus b squared. Well, c squared is equal to 1/9 plus 1. So this is equivalent to 9/9. So I get c squared is equal to 10/9. And when I take a square root, c is equal to root 10 over 9. So my foci from the center, I have to do a distance from the negative 3. So my foci is going to be a difference of negative 3 plus root 10 over 3, comma 5. Because my foci is going to be lying here and here, I have to take 3 plus a distance of 10 root 3, and then I need to take negative 3 minus a distance of root 10 over 3, comma 5 in order to get my other foci. And here we are at example 5, where you're going to find the standard form of the hyperbola given the following information. We know that the vertices are at plus or minus 3, 0, and the foci are at plus or minus 6, 0. So if I graph this to visually see what's going on, if I know that the vertices are at 3, 0 and negative 3, 0, and my foci is at 6, 0 and at negative 6, 0, then I know that I have a center of the hyperbola at 0, 0. I also know, since all of this information is horizontal, that the x squared has to come first. So I know I have x squared over some number minus y squared equals 1. That's what I know so far. The x has to come first because all of my information, my transverse axis, is horizontal. Well, I know that the a is the distance from the center to a vertice squared, so that's 3 squared. And now all I have to do is find the number that goes underneath the y squared and I'm home free. Well, how do I do that? Well, remember, I know that c squared is equal to a squared plus b squared, and I have to solve for b squared. I know that my distance from the center to a foci is 6. I know that the distance from the center to a vertice is 3. So this gives me 36 is equal to 9 plus b squared. So that means b squared has to equal 27. So my final answer is x squared over 9 minus y squared over 27 equals 1. Welcome to example 6, where we're still going to find the standard form of a hyperbola, but the information that you're given is a little bit different. I'm given that the foci is plus or minus 10. So what does that information tell me? Well, if I go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have a foci. And if I go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have a foci. So this tells me that the x squared has to come first because my foci is located on a horizontal transverse axis and the center is equidistant between the foci, so I know that I have a center at 0, 0. Now I need to figure out the numbers that go underneath. Well, I was given that the asymptotes are y equals plus or minus 3 over 4. Here is the problem. I know that if I go up 3 over, like if I go up 1, 2, 3 over 1, 2, 3, 4, that's a point on the asymptote. But so is up 1, 2, 3 over 1, 2, 3, 4. If I keep going up 1, 2, 3 over 1, 2, 3, 4. If I go the opposite direction, 1, 2, 3 over 1, 2, 3, 4, up 1, 2, 3 over 1, 2, 3, 4. These are my asymptotes. These are the equations of my asymptotes. But how do I know how long my transverse axis is, and how long my conjugate axis is? Because this could be my rectangle, but then couldn't this also be my rectangle? And we need to know which one it is. Well, if I know that 3 over 4 is some type of ratio, okay, and I'm just going to use m, that when I try to figure out c squared is equal to a squared plus b squared, I know that c is a distance of 10, but that my a value, my transverse axis, is some multiple of 3 squared plus some multiple of 4 squared. So I get 10 squared is equal to 9m squared plus 16m squared. So that's 100 is equal to 25m squared. So m squared is equal to 4. So that means I want to take the second multiple, or the second point. So when I'm trying to figure out my conjugate axis over my transverse axis, my rise over my run, I need to do 2 multiples. So instead of just going up 3 and over 4, m is 2. So that means I need to go up 6 over 8. So this is going to represent the rectangle that I would use in order to draw my hyperbola. Sorry, my hyperbola would be here and here, and here and here. So this means that when I have x squared minus y squared equals 1, x is the transverse axis, so this distance is going to be a distance of 8. Okay, so it should be right there. That should be a distance of 8. So when I square 8, I get 64. And that this distance is a distance of 6 squared is 36. So my final answer is x squared over 64 minus y squared over 36 equals 1. We're going to find the standard form of the hyperbola, and now we're given the vertices and a point that it passes through. So if I want to just try to get a visual of what's going on with this formula or this problem, if I graph 1, 2, there's a vertice, and if I graph 1, negative 2, there's a vertice. So I know that I have a vertical transverse axis, and the center has to be equidistant between those 2 points. So the center of my hyperbola has to fall at 0, 1. So this tells me that I know that I have y has to come first because it's a vertical transverse axis. So I have y minus 0, the quantity squared, over a squared, minus x minus 1, the quantity squared, over b squared equals 1. Now I can figure out a squared because I know that that distance between the center of the hyperbola and the vertice or the vertex is 2. So I have y squared over 2 squared, which is 4, minus x minus 1 squared over b squared equals 1. So what's different here is I don't know anything about the foci, so using c squared equals a squared plus b squared really is not going to be very helpful. But what they did tell me is that I had a point that passes through. So if this is an x value and that's a y value, I can shove those in to figure out b squared. So if I put root 5 in for y, I would have root 5 squared over 4 minus 0 minus 1 squared over b squared equals 1. So this would be 5/4 minus negative 1 squared is 1 over b squared equals 1. I can subtract 5/4 from both sides. And remember, this is 5/5. This is 4/4, pardon me. So I have negative 1 over b squared is equal to negative 1/4. When I cross multiply, negative b squared is equal to negative 4. So b squared is equal to positive 4. So when I put that all together, I know that y squared over 4 minus x minus 1 squared also over 4, yes, your transverse and your conjugate axis can be the same, is equal to 1. And welcome to example 8, where we're going to write an equation of a hyperbola. Again, it's just the information that they're giving you is a little bit different, and you just have to think through it. So they tell me the vertices are 3, 0, and 3, negative 6, and then they give me the equation of the asymptotes. So again, I'm pretty visual. Let's see what's going on here. Let's plot those points and see what's going on. So at 1, 2, 3, 0, and then at 3, 1, 2, 3, 4, 5, 6, I have vertices. So automatically I know that I have a vertical transverse axis. Furthermore, I know the center is not at 0, 0 because the center has to be smack dab in between those vertices. So if I count 1, 2, right there, that has to be the center of my hyperbola. So I know that this center is at 3, negative 3. So that means I have y plus 3, the quantity squared, over some number, minus x minus 3, that shouldn't be an h, x minus 3 squared, over some number, that's going to equal 1. Well, I can figure out the number that goes underneath the y squared very easily because I know that the distance from the center to the vertice, or half of my transverse axis, is 3. So that's going to be a 3 squared, which gives me 9. So what do I have so far? I have y plus 3, the quantity squared, over 9, minus x minus 3 squared, over some number to be determined equals 1. Now, I have these asymptotes. So if you notice, regardless of how the asymptotes go, I have one asymptote going this way and another going this way through the center. And so the slope of this line is 1, and then the slope of this line is negative 1. So I know as I go up and over that is going to be my slope. My slope is my change in y over my change in x. Well, I know that my change in y is 3. I don't know my change in x, and once I find that change in x and square it, it's going to go here. But what I know is that it's equal to 1 or to negative 1. So let's just look at the positive, because let's just look at this line. It makes it easier. Well, if I know that this is 1, then the denominator has to be a distance of 3, so that 3 over 3 is 1. So I have to go up 3 and out 3 to get to that line. So that means this is 3 squared. So the number underneath that axis is also 9. You are now ready to continue with the next part of the assignment, which is begins on page 656, and try 15 to 43 the odds. Good luck.